So for this example, right? So it's not difficult at all. It's pretty straightforward. The only difficulty is what section consider what load. Okay, and that's based on the hangman. So to summarize on this example, is the first thing we'll do, you divide the structure into components at the load, okay, or at either change in cross-sectional area or length, okay, use of different material, okay. Then you apply free body diagram on each subsection to determine the internal force. That's what our P1, P2, P3 are. And then we apply, we evaluate based on deflection. So we use PL over AE. Notation is tensile is positive, compression is negative. Okay. And then you divide your structure. Then you remember about the hangman. Okay. You just remember how the hangman is applied. And then we just put everything in. Okay. Consider what load and find the total. Now, question for you guys. I got a good question. Now, what if we look at this hangman, what if now I push a total load of P on the man's feet? Can you all tell me, will the hip and the legs feel the P? Yes or no? Anyone?
Yes.
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 Right? Will the lower body feel the P?
Yes.
Yes. Right? Will the upper body feel the P?
Yes.
Interesting, isn't it? Right? Okay. It will feel the P. Okay. It will feel the P. So you have to be really cautious down there. Okay. This is where things get interesting. Okay. So now we are going to do a slightly it's not more difficult, slightly different problem. Okay. So the next question, the next example. Okay. Now you're clear with this, yes or no? Right? Simple to understand, right? Nothing too complicated. Am I right? Okay. Right. So I'm going to, so if, as I said, if you go to Avenue, okay, I want you to download this question on Avenue to learn. We're going to do this question now. Okay, we're going to take the image. Okay. So this is example. Okay, so this is our example number 2. And this example is statically indeterminate. Okay, this example. So we're going to apply what we have learned earlier. Okay, we're going to apply what we have learned earlier. So what you can see over here now is that there's a support at point D and there's a support at point C. Okay, so both of them are have support. And I've also deliberately, this is the solution. Okay, this is the solution. So this term, so this is the solution. I'm going to string it down. Now, sometime your homework, I give you solution. The solution are only used for checkpoint. Okay. Don't try to figure out what they are doing because I don't understand any of this at all. How they get this, I have not a clue. What is this? I have not a clue. Why they put all this, not a clue. Why they get this value, I don't know. Okay, because they're going to solve it in a different method. So I'm going to solve this based on what I taught you earlier and what I taught you last week. Okay, so all this solution, but what is important in all this solution? Okay, what is important is for all this the solution, if I do pose, are all these numbers. All these numbers are your checkpoint. If these numbers are wrong, then there's something wrong, okay, with the analysis. So these are the checkpoint. So look at the checkpoint. Okay, what I'm trying to say is look at the checkpoint. Don't follow blind. Like for this case, all of a sudden he decided to use summation about forces. Like over here, you can see all of a sudden you see summation about forces in the x direction. Towards the left hand side is positive, is equal to 0. Do you know why? I don't know why. Do you want to spend time to figure out? No, I don't want to spend time to figure out. Absolutely pointless. I would rather apply a technique. What I've taught you. Okay, so don't waste time. So to start this problem, right, we have to look at this structure now. So we know that this structure we have to divide into 3 different sections, right? So we know the section to divide is D to A to B, B to C. But let's read the question further. Okay, let's read the question further. So the composite bar, okay, of 20 millimeters. So we know that where this 20 meters is made of A 36 steel. So this over here is A 36 steel. Okay. And the 50 millimeters diameter is made of red brass. So this section over here is made of brass. And this section over here is also made of brass. Okay. So the first thing we're going to do is we're going to prove, okay, we're going to prove that the structure is statically indeterminate. Okay. So we construct the free body diagram. Okay. So on this free body diagram, we have X and we have Y, and over here is our rotation about Z. Okay, so we start with that first. So we have 50 and 250. So I'm going to draw. Okay, so this is so this 50. Okay, so 250. And then the next section is 500, 20 and 500. Okay, so it's a longer part. And then finally, it end off with this. So this is our free body diagram. So on our free body diagram, so this is our point D. Okay, so this is our point D, our point A, our point B, our point C. Okay. And we are also made aware that over here, we have a load going in this direction, pushing at 150 times 10 to the power 3 Newton. Okay. And on the other side, we have 200 times 10 to the power 3 Newton. Yeah, we have those. Now the next thing is we are going to find out point D. Can anyone tell me point D? It should be pointing towards the left or towards the right. What is a good guess? Anyone, please? Anyone? At point D,
Right.
towards the right. Anyone else?
Left.
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 Left. So if you look at what I taught you, is it? I've taught you last week. Let me see. Let me see.
I made that mistake last week.
You made that mistake last week. Did I teach that last week, right?
Yeah.
Hold
The
on.
man pushing on the two walls.
Yes, the man pushing on the two walls. Let me look at where is the man now. Right. Can you see the man pushing the two walls? Yes or no? Right. So it's exactly like what you see down here. It's exactly the same problem, right? So if you're to push outwards, then the structure will stay. If the structure, when I say the structure is the centerpiece, if it push inwards, it will drop. Okay. So if we know that over here, this is your first guess. So this is your dx, and then over here, right? This will be your. This will be yeah. This will be your cx. Okay, and then I will draw for you the if we are given a wall. I'll do it again, right? If these are the walls, right? If you are the center, to keep yourself afloat, you have to be pushing what? So these are all your elbows, your knees. You have to be pushing what? Outwards. Yes or no? Then
Yes.
you will stay hanging on the wall. Okay, so you will not drop down. Okay, there's a lot about hanging. Okay, so don't take this personally. Okay, don't like we are going to die. Okay, don't take this personally, please. Okay. All right. So the first thing that we do, right? As I said, this is the first part. I'm going to prove to you that this part is statically indeterminate, which we have done a bit last week. So we are going to apply static analysis. Okay. So the first thing we do, okay, let's look at summation about forces in the y direction is equal to 0. So what you see over here, you have no forces going up. So basically this equation is gone to waste. So this will be equal to 0. You cannot form any equation at all. Then okay, let's try the next one. Summation about moment in the z direction, and you are taking your moment about point A. Okay, so you take your moment at point D equal to 0. So this is where you take where I'm drawing the circle now. Okay, this is where you take your moment, and then when you realize that hey, moment is equal to force by perpendicular distance, you have nothing. You have force, right? 150 is a force, 200 is the force, but there's no perpendicular distance. So forget it. You have nothing again. Then the last one is you can do summation of forces in the x direction is equal to what? 0. Okay. So you will have minus dx, right? Minus 150 times 10 to the power 3 plus by 200 times 10 to the power 3 plus by cx is equal to what? 0. So over here you will have your form cx minus by dx. this will be equal to minus 50 times 10 to the power 3. All right. And this is what I call my equation number 1. Okay. So Cx minus dx equal to minus 50 times 10 to the power 3. So more or less, if you look at the solution, they have a formula very similar. Okay. But it went